Here is a view of olabs interface for computer science. You have the program source code at the left and the hardware registers at the right bottom. The memory segment is divided into three parts. The first is the code segment, which contains the low-level instructions that matches this particular program. And then you have a data segment, which contains the global variables used by the program. And finally, the stack segment, which contains the local variables, the parameters passed, and the return values of a function. Your program source code is first converted into these low-level instructions, which is understandable by your hardware before the execution actually starts. The conversion can happen either during the compile time or during the runtime. The data segment contains the global variables which will be available throughout the execution. On the other hand, on the stack segment, whenever a function is being called, then the local variables come into existence, and once the function finishes, they cease to exist. Let's now run the program that computes the sum of two numbers and visualize what happens. The instructions are executed from the code segment. This is what the hardware sees. So let's get started. As a first step, the global variables a, b, and sum are loaded into the data segment. And then value of a and b are assigned. You use the assign instruction, which actually sets the value of a and b. Some value it is not yet set. It has to be computed. Let's see how it works. First we load the value a from the data segment to the register R5, followed by b to register R1. Now the add instruction can come in, and given the registers, using the wirings underneath, it would add and put the value, that is the result, on the first register R5. Now the computed sum is stored back to the value sum. Finally, the print statement, which is an out instruction, outputs the value 50 and the program exits.